We've already talked in Chapter 3 about why conservation of momentum is important. But now that we're starting to get an idea of what a system is, let's look at what the momentum of a single system would be. So we can write the momentum of our entire system as the momentum of particle 1 plus the particle 2's momentum, and do the same for however many n particles we have in our system. So the total momentum is just the sum of each individual piece of momentum. So so we already saw this in the last chapter. We said that if we have particle A and it has some initial velocity, and we have particle B which has some initial velocity, then we said the total momentum was the momentum of particle A plus the momentum of particle B initially, and that would be conserved even after the collision. That momentum wouldn't change. So looking at the example that we gave in the last video, so we said, what if we say we have this big cloud, this big gas of atoms in a box. So we have the atoms and we have our box. Okay, so the total momentum is just the sum of of all of the particles in the box. Okay, classically we're making the approximation that this box does not move. Now, as we'll see as we get through this chapter, that's actually not a very good way to look at the system, and we'll talk about why. But for now, whenever we talk about a system of particles in a box, we're assuming that this box, this thing that's external, isn't moving at all. It's only the things that are internal that are moving.